Okay. So coming up next is skill number 6. I think one of the top 6 skills in the first chapter. Har har har. There are only 6 skills in the first chapter, but this is among the best of them. This is about manipulating formulas. So this is, it's a little bit more algebra sort of focused than it is maybe geometry focused, but we are going to be sort of using some of our geometry formulas. So this is a little bit of a mix. It's sort of a hybrid chapter. So sort of wrapping up some geometry concepts and sort of mixing in some of these algebra ideas. It's a very sort of general section, sort of a general concept that is sort of trying to manipulate these formulas. What we mean by that is sort of looking from a math perspective at different formulas. We're going to see a whole bunch sort of still coming up and in the future, and of course in your technical courses. And part of the idea is when we see a formula, we want to be able to obviously sort of use it going forwards to a certain extent, but we also want to be able to kind of unpack it and sort of reverse it, and sometimes find a piece from the middle and solve for that. A formula that has however many variables, 3 different variables, it's not just a formula to find one of the things. In theory, it's a formula to find any of those 3, depending on the kind of information you're starting with. What we're going to use initially as sort of a reference here is the torque formula. Torque is a concept that I still don't totally understand, despite having many automotive students try to explain it to me. That's not their fault, of course. I think it has something to do, it sort of is like a turning kind of strength, right? Like a torque wrench, right? Sort of the more torque you have, the more like turning power you have, maybe. I'm not totally sure. In any event, what we're going to be using here for torque in an automotive perspective is this formula. So our torque is going to be equal to, so this is a constant, 5252, 5,252. So this is a constant times whatever our horsepower is, and then the whole thing is divided by the RPMs. So this torque, right, this sort of turning strength or something, turning power, is related to horsepower and RPMs. It comes in the somewhat nonsensical to me units, foot-pounds, feet times pounds. And underneath there is a relatively sort of intimidating setup that walks you through sort of where those units come from, and also sort of justifies where this 5252 comes from. The short explanation is 5252 comes from doing the unit conversions necessary to sort of end up in foot-pounds. Right, and so it's sort of related to, you have your sort of horsepower units, you have your kind of RPMs, and there's just a lot of sort of shifting things around to kind of go through all this and end up with this 5252 and end up with foot-pounds as your units. We're not going to linger too much on that. We're just going to sort of take everybody's word for it that has sort of gone through this before us. We will trust in their work, and we will sort of move ahead. So the first thing that we're going to sort of do in this chapter is essentially just like, do a calculation with the formula, just like in order, more or less, right? Just sort of what is the normal version of this formula. So that is, our measurement for torque is coming from horsepower and RPMs. So if I know the horsepower and I know the RPMs, I can sort of sub it into my formula and find the torque. So determine the torque of a 120 horsepower engine that's operating at 2400 RPM, right? So all I'm going to do is throw these values into my formula. So this is it, right? So my torque, I'll kind of rewrite it here. 5252 times horsepower over the RPMs. So if all I'm doing is subbing these values in, 2400 for the RPMs is on the bottom, 120 for the horsepower is up top. no problem. This is just a quick, right? 52 times the 120 is 630,240, and then divide it by the 2400. In this case, can you guys see? Yeah. We're going to end up at 262.6 foot-pounds for torque. So just running this formula in order, right? There's nothing particularly kind of wild about it. I mean, there's multiplication and there's division, but that's fine. Right, so 5252 times the 120, and then you're dividing by the 2400. And there you go. Now, so what comes next is, right, say we have the torque formula sort of as a reference, but we want to sort of use it and kind of unpack it and rearrange it to solve for more of these other values. So maybe we're in a torque situation, a torque adjacent situation. But the second example here is asking us to manipulate the formula, right, meaning sort of rearrange it so that it is solved for horsepower. So I want, right, horsepower is equal to kind of ... you know, in terms of what would then be sort of torque and my RPMs on the other side. So the basic idea here is we'll start with our torque formula, right? So torque 5252 times horsepower over my RPMs. I'm kind of squeezing it in here. So mathematically, what I'm trying to do is I'm trying to get to horsepower. So I'm trying to just do algebra steps to get to this horsepower. I need to essentially just unpack whatever's here. This is an equation, right? A formula is sort of another way of saying equation. And so I can do pretty much any kind of math steps that I want. I can multiply, I can divide, I can add, I can subtract, I can even to a certain extent, you know, raise things to powers or sort of take roots. I have a lot of different options here, provided that I do the same thing to both sides of this equation. So I need to be strategic and sort of pick the steps based on where I'm trying to go, what my sort of goal is. In this case, to get to horsepower. So what I'd like to do is shift everything away from the horsepower, right? In the most generic sense, I'm trying to just move everything away from horsepower and get it by itself. My first step is I want to get rid of the RPMs that are on the bottom. So this is divided by RPMs. How do I get rid of division? What I'm going to do is I'm going to multiply both sides, right? Multiply both sides by the RPMs. So when I do that, you can sort of see here, right, when that RPM is not crossed out, that's just our original formula. So if I multiply both sides by the RPMs here cancel out, and then I sort of gain the RPMs on the other side. You can almost visualize this is sort of cross-multiplying RPMs over from the right side to the left. That would leave me with, I'll cover this up, you know, RPM times torque would be 5252 times horsepower. Kind of squeeze this in maybe. Right, that's kind of the middle step, and so then I'm trying to get, again, of course, horsepower by itself. So what I want to do now is get rid of the 5252. I need to sort of shift it over. So how am I going to do that to get rid of 5252? Well, now it's sort of multiplied by the horsepower. If I want to undo multiplication, what I'm going to do is divide. So I'm going to divide both sides by the 5252. Just a constant, right? It's this sort of constant that does all these unit conversions. So if I divide that out, divide from both sides, right? Divide both sides. So 5252 cancels out. I sort of gain it on the bottom over here. And what I'm left with is essentially a new version of this equation, right? So I'm left with, you know, what would be sort of horsepower by itself. And then the other side here is RPMs times torque over the 5252. You can kind of see in unpacking this, we've sort of rearranged also a little bit like what these operations are. I want to look at another one from the exercises. I want to look at number 7. You could imagine, right, so you have sort of torque. We just did it where we sort of rearranged it and we solved it for the the horsepower. So let's do another one. The sort of third version here would be solving for the RPMs. So number 7 here says determine the RPM of the following engines and state which is higher, right? Which of these two has the higher RPMs. So let me bring this information over. I'll sort of rewrite what we've got. Skill number 6. Problem number 7. So I've got engine number 1, 125 horsepower, 345 foot-pounds of torque. Engine number 2 is 300 horsepower, 520 foot-pounds. So what I'm trying to figure out is find the RPMs for each of these and then just sort of see which is higher. So I'm going to start with my torque formula, right? So my torque should be 52 times my horsepower over the RPMs. So what I want to do is rearrange this equation. I'd like to get a version of this that's solved for the RPMs instead, right? And then I can sort of sub these values in and I can compare them. So I'm going to do the same kind of first step that I did in the last one, which is multiply both sides by the RPM. Cancel, cancel. So that means the RPM times my torque is equal to 52 times my horsepower. I'm trying to isolate the RPMs, right? That's what I'm trying to get by itself. So what I'm going to do is divide my torque over to the other side. So what I get here, right, is sort of a new version of this equation. My RPMs would be 52 times the horsepower, but divided by the torque instead. You know, in some sense, what's happened here is my RPMs and my torque have essentially flip-flopped. They've sort of changed places. Once I sort of have this, all I need to do is sort of plug in my values for the engines, and I'm good to go. So let's just kind of crunch these numbers relatively quick. So number 1, RPM. So 52 times my horsepower was 125 over now my torque, which is 345. 5252 times 125 divide by 345. 1902.9. So 1902.9 RPMs. So that's engine number 1. Engine number 2. Same basic setup. 52 times 300 horsepower over 520 foot-pounds. I'm kind of leaving the units off here. If only, you guys can still see the, oh no, the engines are up there a little bit, right? Those are my numbers. So I'm just bringing them down. So quick number crunch. 5252 times 300 divided by 520, 3030. Oh, that's much bigger. 3030 RPM. Oop. So engine number 2 is larger. Or no, is spinning at a higher RPMs, right? I shouldn't say larger. I should say higher RPMs are for engine number 2. So, you know, there's different versions of this. You could kind of do something where you sub the numbers in first and then you rearrange it. That works. You know, from an algebra perspective, rearranging first is sort of a good move because then you sort of get just a new generic formula that can be used for anything. But it's whatever you're more comfortable with. That's the idea.